So extreme values occur at critical points or at the endpoints of a given interval. So critical points happen where the derivative equals 0 or where the derivative fails to exist. So we'll take a derivative like we usually do. The 2 halves comes down, and then 2 halves subtracted by 1. That's negative 3, 2 halves, sorry, 2 fifths. That's 2 fifths, and this is negative 3 fifths. That's our derivative. We set it equal to 0, and we usually don't like negative exponents because it can make us miss divide by 0 problems, right? Which this question has. Critical points are where the derivative equals 0 or where the derivative fails to exist. So x equals 0 is a critical point. So once you've identified your critical points, you want to check the y values on the endpoints and at the critical points. Okay. So x equals 0 is one of our critical points. That's the left endpoint. That's the right endpoint of this interval. And if you plug in negative 3 into this function, let me see how we could do this without a calculator. 2 fifths, that's the same thing as x over x to the 3 fifths. That doesn't help us. What can we do? Okay, I think I've got it figured out. So one way of thinking about rewriting this function is that it's the same thing as x to the 1/5 power squared, right? Because powers on top of powers multiply. So what I've rewritten is still the same thing. 2 times 1/5 is 2 fifths. And if you're squaring something, it's always going to make it positive. So when we plug in negative 3, you're going to have negative 3 to the 1/5, but we can just call that a positive 3 to the 2 fifths because no matter what we plug in here, it's going to be positive. So what was I doing? This is 3 to the 2 fifths. Okay, and again, it's not negative because the way I rearranged it means we're always going to have positive numbers coming out of it. If you plug in 0 into this function, 0 to the 2 fifths is just 0. And if you plug in 1 into the function, 1 to the 2 fifths is 1. Okay. So 3 to the 2 fifths, we probably want to know what that is as a decimal. So 3 to the 0.4 power, 1.55. So this is the highest y value out of all the critical points and out of all the endpoints. So that means this is our maximum. The lowest y value here is at 0, 0, so that means that's our minimum. And then this would be a local max if you want to identify that too. But I think the textbook's just looking for your maxes and mins on the interval.